Deep beneath the surface of our world, hidden in rock layers older than any civilization we've ever known, lies a mystery that scientists can't quite explain. Microscopic spheres of rare metals, the kind normally linked to high-temperature industrial processes, have been discovered in formations that predate humanity by millions of years. To anyone who studies them closely, they look eerily similar to the fallout left behind by modern nuclear tests, and yet they cannot possibly belong to us, or at least not to the civilization we recognize as human. For generations we've believed we were the first to build machines, the first to split atoms, the first to manipulate the very chemistry of our planet. But what if that belief is wrong? What if buried in the archives of geological time is proof that Earth was home to others before us, civilizations that rose, advanced and vanished without leaving behind the monuments or histories we expect, but instead subtle fingerprints etched into stone and ice? The story begins with a realization so profound it shook science at its core. In 1980, a geologist named Walter Alvarez uncovered a thin band of clay in Italy. At first glance it looked ordinary, but testing revealed something astonishing. It contained levels of iridium 30 times higher than normal. Iridium is scarce on Earth, but common in asteroids, and this strange concentration became the smoking gun for the asteroid impact that wiped out the dinosaurs 65 million years ago. In that moment, scientists understood something extraordinary, that even a single catastrophic event could leave a permanent scar on the geological record, detectable tens of millions of years later, which led to the question that refuses to go away. If an asteroid can leave its signature so clearly, what would be left behind if an advanced civilization had once walked this planet? This question eventually evolved into what scientists now call the Silurian hypothesis, a thought experiment that dares to ask whether industrial civilizations could have existed long before humans, their traces misinterpreted as natural phenomena or simply eroded by time. Think of the scale of Earth's history. Our industrial age has lasted barely 300 years, yet even if it stretched for 10,000, that entire story would be less than a fraction of Earth's 4.5 billion year history. To put it in perspective, finding evidence of us millions of years from now would be like trying to find one page torn from a library of 4 million books. Still, traces should exist. Carbon dioxide emissions, artificial isotopes, synthetic materials, these things last. They become woven into the layers of stone and ice, markers that say someone was here. And this is where the story takes a turn, because when geologists and paleontologists began looking with this new lens, they started noticing anomalies, gaps in the fossil record where life seemed to leap forward too suddenly. Chemical signatures in rock that resembled massive combustion events, odd distributions of metals and materials that on the surface should not exist in the quantities or patterns found. Were they simply quirks of nature, or the byproducts of technologies long forgotten? These questions invite us into unsettling territory, a place where science blurs with speculation, and where the past of our planet might be far stranger than we've dared to imagine. So tonight, we peel back the layers of deep time and examine the evidence that challenges everything we think we know. From vanished nuclear signatures to synthetic materials hidden in ancient sediments, from the sudden appearance of complex life to strange structures buried under Antarctica's ice, each clue leads us closer to one haunting possibility: that humanity may not be the first advanced civilization to walk this earth. And if we are not the first, the question that follows is even more chilling. What happened to the ones who came before? The first clue that something may be missing from our story of Earth lies within the fossil record itself, the ground archive of life written into stone. On paper, this record should read like a continuous book, page after page detailing the rise and fall of species across billions of years. Yet when scientists examine it closely, the book doesn't flow smoothly. Instead, it feels as though huge chapters are missing, entire sections ripped out, leaving behind only fragments that hint at stories we can't fully reconstruct. Perhaps the most famous of these puzzles is what scientists call the Cambrian explosion. Roughly 540 million years ago, the fossil record suddenly shifts from simple organisms like algae and bacteria to an ocean teeming with creatures that seem impossibly complex for their time, animals with eyes, shells, limbs, and intricate body structures that should have taken countless millions of years to evolve. But the evidence shows they appeared almost as if overnight. Geologically speaking, no gradual transition, no slow build-up, just an explosion of complexity that defies the rules of evolution as we understand them. Traditional explanations exist, of course. Scientists point out that soft-bodied organisms, the kind that dominated before the Cambrian, rarely fossilize well, meaning that intermediate forms may simply have vanished without leaving a trace. Others argue that environmental conditions finally aligned to preserve fossils more effectively, giving the illusion of a sudden leap. But even with those explanations, the sheer scale and speed of the Cambrian explosion remains unsettling. It is not the only mystery either. Throughout Earth's history, we see similar moments where life abruptly changes course. Species vanish without clear cause, and entirely new forms appear as if they were waiting in the wings. Sometimes these shifts coincide with dramatic changes in the atmosphere, sudden spikes or drops in oxygen levels, or unexplained chemical signatures in the rocks that suggest events too large and too precise to be dismissed as coincidence. To some, these anomalies look suspiciously like interventions, the kind of sweeping environmental manipulations that an advanced civilization might leave behind. Consider the Great Oxidation event around 2 billion years ago, when oxygen levels in Earth's atmosphere skyrocketed in a relatively short geological window. This event poisoned most of the life that existed at the time, but paved the way for more complex organisms to evolve. The official story credits cyanobacteria, microbes that developed photosynthesis, as the driving force behind the change, but the precision and timing of the oxygen spike raises questions. Could a natural process alone have transformed the planet so dramatically, or does this bear the hallmarks of deliberate planetary engineering, an attempt to reshape the atmosphere itself for new forms of life? The fossil record is full of these gaps and leaps, moments when life seems less like an uninterrupted chain and more like a series of abrupt resets. And then there are the extinctions, massive wipeouts that appear with startling regularity. Entire species swept away, ecosystems collapsing, followed by rebounds where new life suddenly flourishes in unexpected forms. Natural disasters like asteroid impacts and volcanic eruptions are often blamed, but in some cases, the chemical traces left behind resemble massive industrial-scale combustion or atmospheric alteration rather than natural catastrophe. These gaps and sudden shifts could be nothing more than quirks of preservation, the randomness of which creatures survived and which did not. But they could also be something more. A quiet record of civilizations rising, transforming the planet in ways we barely recognize, and then vanishing so completely that only their fingerprints remain hidden in the layers of stone beneath our feet. If the fossil record raises questions about sudden leaps in life, the rocks themselves whisper even stranger secrets about what may have transpired on this planet long before us. Deep beneath our feet, in layers of sediment that have remained undisturbed for tens of millions of years, scientists have found chemical anomalies that refuse to fit comfortably within the natural narrative. One of the most famous examples comes from the discovery of iridium, a rare metal scarcely found in Earth's crust but abundant in asteroids. When geologist Walter Alvarez first identified an iridium spike in the rock boundary marking the end of the dinosaurs, It was hailed as proof that a giant asteroid had struck Earth 65 million years ago. That single discovery changed science forever, demonstrating that catastrophic events can leave behind chemical fingerprints so strong that they survive across vast epochs of time. But that very realization also opened a new and deeply unsettling question. If one asteroid impact could be etched so clearly into stone, what other signatures might we find that point not to natural disasters, but to technological activity? The further geologists looked, the more peculiar the record became. At the boundary between the Permian and Triassic periods, roughly 252 million years ago, they found carbon isotope ratios that mimic exactly what happens when massive amounts of fossil fuels are burned in a short span of time. The spike was so extreme, it would be the equivalent of setting fire to all known reserves of coal, oil, and natural gas on Earth simultaneously. The mainstream explanation invokes volcanic eruptions or methane release from the oceans, but the eerie similarity to modern industrial emissions is difficult to ignore. It is as though the planet itself once experienced the same kind of carbon-intensive industrial activity we are producing today, only it happened long before any humans were here to cause it. Other anomalies push the mystery further. In Colorado, rock formations contain microscopic spheres of titanium and other rare metals, identical in structure to particles produced by high-temperature industrial processes. These are the same types of byproducts created in modern smelting and combustion facilities, yet they are locked in geological layers far older than human industry. In oceanic sediment cores, scientists have uncovered traces of synthetic compounds, molecules so complex they should not exist naturally at all. The layers in which they appear predate human chemistry by millions of years, leaving only two options. Either some unknown natural process is capable of producing substances that look like advanced synthetics, or another civilization manufactured them long before we appeared. Even more puzzling are the discoveries in Antarctica and Greenland, where ice cores have preserved snapshots of the atmosphere stretching back hundreds of thousands of years. Within these frozen archives, researchers have identified sudden spikes in greenhouse gases, sharp rises in carbon dioxide and methane that mirror the exact patterns of modern industrial activity. These episodes of rapid atmospheric change linger for thousands of years, then fade back into natural baselines, as if the civilization responsible for them either collapsed or found a way to clean up its mess. The repetition of this cycle throughout deep time suggests a disturbing pattern. Civilizations may rise, industrialize, transform their atmosphere, and then vanish, leaving only chemical shadows behind. But perhaps the most striking evidence comes in the form of radioactive isotopes. Human nuclear activity produces unique signatures, artificial elements that do not occur naturally and persist in the geological record for millennia. When scientists examined uranium deposits in Gabon, Africa, they found evidence of self-sustaining nuclear chain reactions that had taken place 2 billion years ago. While officially described as a natural reactor created by chance geological conditions, the find demonstrates a crucial point. Nuclear activity leaves unmistakable isotopic fingerprints that last for billions of years. Now consider that similar anomalous isotopes, patterns strikingly close to those created by nuclear detonations, have been discovered in rock layers that predate human civilization by tens of millions of years. These signatures are too precise to dismiss as coincidence. If they were the product of natural processes, those processes remain entirely unknown to science. If they were not natural, then the conclusion is almost unthinkable. Advanced civilizations capable of nuclear technology may have walked this Earth long before us. Taken together, these clues, iridian spikes, anomalous carbon ratios, metallic spheres, synthetic polymers, greenhouse gas anomalies, and radioactive isotopes, begin to weave a story far stranger than anything we were taught. The Earth remembers everything. Every fire, every factory, every nuclear blast leaves its mark somewhere in the layers of stone, ice, or sediment. Our own activities today will be written just as clearly into the record, waiting for some future intelligence to decipher. And if we can read our own signatures so easily, then perhaps we are only now beginning to recognize those of civilizations that came before, their legacies hidden not in monuments or ruins, but in the unyielding testimony of the rocks themselves. If chemical signatures and radioactive isotopes suggest strange activity in the distant past, the next layer of mystery comes from materials that seem too artificial, too engineered, to belong in the deep geological record. Our own civilization is producing an unmistakable material legacy that will endure long after our skyscrapers and machines have crumbled into dust. Plastic. Unlike wood, stone, or even metals, plastic resists decay in ways that make it a geological time capsule, buried in sediments, locked beneath ice, or scattered across ocean floors. Microscopic plastic particles will remain detectable for millions of years. They are so distinctive, so alien to natural processes, that future geologists could identify the moment of humanity's industrial rise by nothing more than a sudden layer of polymers in Earth's strata. But unsettlingly, evidence is emerging that we may not be the first civilization to leave such markers behind. Sediment cores from remote ocean basins have revealed the presence of microscopic particles that look eerily like synthetic polymers. These fragments are chemically stable, resistant to natural degradation, and clustered in layers that date back millions of years before humans ever conceived of modern plastics. At first, scientists proposed contamination from drilling equipment, but repeated findings across multiple sites ruled that out. The particles are arranged in discrete layers, separated by vast spans of geological time, as if civilizations had risen, manufactured materials on a global scale, then disappeared, leaving their polymer fingerprints embedded in the seabed. Some layers contain compounds that appear even more advanced than what we currently produce, engineered to resist ultraviolet breakdown, chemically fortified to endure in environments harsher than any we design for. If these are artificial, they represent material science that surpasses ours, developed by beings we no longer recognize. The Antarctic ice sheet adds another piece to the puzzle. Deep drilling projects have recovered ancient layers of ice that contain tiny polymer fragments locked within, perfectly preserved by the cold. These samples date back hundreds of thousands of years, long before our civilization's rise. Their molecular structure shows signs of engineering, with configurations that suggest optimization for strength and resistance to chemical corrosion. These are not molecules one expects to find in nature, yet there they are, suspended in frozen air bubbles, as silent witnesses to activities that should not have been possible at the time. The implication is staggering. If plastics or polymer-like substances appear in contexts this ancient, then either our understanding of natural chemistry is missing something profound, or civilizations capable of manufacturing synthetic materials existed long before us. Even more startling are discoveries in Australia, where unusual mineral deposits were initially thought to be naturally occurring. Closer analysis revealed that these minerals were actually degraded fragments of synthetic compounds, some still retaining their molecular complexity after millions of years. Radiocarbon dating of surrounding organic material placed these layers far outside the timeline of human industry. And yet, the synthetic fragments were unmistakable, engineered structures not found in natural chemistry. The question then arises, who made them and why do their remnants appear to persist across multiple continents, suggesting a civilization with global reach? Modern science has only just begun to grapple with what this means. Some researchers cautiously propose unknown natural processes, bizarre chemical pathways that mimic synthetic structures. But the more we look, the more patterns emerge that defy coincidence. These polymer traces are often found alongside other anomalies, carbon spikes, isotope shifts, and metallic spheres that point to periods of intense industrial activity followed by abrupt silence. The record reads less like random chance and more like chapters of forgotten histories, civilizations that rose, altered the earth, then vanished into deep time. And perhaps most haunting of all, some of these polymer fragments contain molecular structures beyond what we are capable of today. Enhanced durability, chemical resistance, even features that suggest they were designed with self-healing properties, qualities that hint at a level of sophistication we have not yet reached. To imagine that long before us, some unknown civilization engineered materials superior to our plastics is to confront a chilling possibility that technological societies may not only have existed before, but that they may have achieved advancements that still outstrip our own. These silent shards, embedded in ice, stone, and ocean mud, tell a story of permanence. Buildings fall, machines rust, bones turn to dust, but plastic endures, as will our own. If we are now uncovering traces of similar synthetic materials in strata millions of years old, then it suggests Earth has recorded not just the rise and fall of species, but the repeated experiments of intelligence itself. Perhaps the legacy of every industrial civilization is not monuments or ruins, but the quiet persistence of the unnatural synthetics that should not exist, yet do. And if so, the question is no longer whether others came before us, but how many times the cycle has already repeated. If synthetic polymers and strange chemical residues hint at the fingerprints of forgotten civilizations, the air itself may carry even deeper secrets. Earth's atmosphere is more than just a blanket of gases. It is a living archive of planetary history. Each volcanic eruption, each mass extinction, every industrial activity leaves behind signatures encoded in trapped bubbles, frozen ice, or altered chemical balances. When scientists drill deep into the Antarctic and Greenland ice sheets, they recover more than frozen water. They recover time capsules of air that stretch back hundreds of thousands of years. What they've discovered in those samples is both fascinating and troubling, because within those layers are sudden, systematic changes in atmospheric chemistry that don't align with any natural cycles we know. Normally, climate shifts occur gradually, driven by orbital wobbles, solar variation, or volcanic activity. But several times in Earth's past, concentrations of greenhouse gases like carbon dioxide and methane spike abruptly, rise to staggering levels, linger for thousands of years, and then fall back to baseline almost as if someone had pressed reset. These events are scattered across hundreds of thousands to millions of years of ice core records. The spikes look eerily similar to what we are doing right now with fossil fuel combustion and industrial output. To chalk them up to coincidence would be convenient, but the precision and consistency of these patterns suggest something more deliberate, almost engineered. What if, instead of random natural events, these were the atmospheric signatures of earlier civilizations consuming energy at planetary scales? Ocean sediments add to the mystery. Within their layered deposits are traces of compounds that don't occur naturally yet show up in concentrations too high to ignore. Some of these compounds are highly effective greenhouse gases, molecules that trap heat far more efficiently than carbon dioxide, and whose structures suggest they were designed. The strange part is that they appear in controlled ratios, as though released intentionally to manipulate climate rather than accidentally through uncontrolled pollution. It raises the possibility that ancient civilizations were not just burning fuels, but were actively geoengineering, deploying atmospheric chemicals to regulate planetary temperature, rainfall, or even shield themselves from cosmic radiation. If true, this would mean that millions of years before humans thought of climate engineering, others were already experimenting with atmospheric manipulation on a global scale. The soil record tells a similar tale. Fossilized soils from certain time periods showed dramatic shifts in nutrient balance and precipitation patterns that don't align with known natural causes. These shifts, however, line up with the atmospheric anomalies found in ice cores, hinting at coordinated manipulation of climate across continents. One interpretation is volcanic activity or methane release from permafrost, but another, more unsettling explanation is that industrial civilizations deliberately restructured their environments to suit their needs. The scale of these changes points not to accidental side effects, but to calculated, sustained projects that might have lasted millennia. And then there are the strangest findings of all: air bubbles trapped in amber from the age of the dinosaurs and even earlier. Some of these samples show oxygen levels elevated well beyond what Earth's plants could naturally produce, paired with isotope ratios that don't match known biological processes. The enrichment looks artificial, as if someone had engineered the atmosphere itself to support larger populations, different metabolisms, or even life forms alien to the ones we know today. To imagine that someone not only understood, but could control oxygen levels at planetary scales is to confront an intelligence that treated Earth's entire atmosphere as an engineering project. It suggests not just survival but mastery, the ability to bend climate and air into tools of civilization. Yet even such mastery may have been a double-edged sword. Just as our own climate experiments carry risks of unintended consequences, the record shows sudden collapses, periods where atmospheric chemistry spiraled into instability, only to later reset. These shifts resemble failed interventions, experiments abandoned after catastrophic results. Perhaps ancient civilizations, like us, tried to push their technology to stabilize a chaotic climate, but instead triggered disasters that erased them from history. The scars remain in the form of abrupt climate swings, frozen in ice and stone, as warnings for those who come after. What makes these discoveries most unsettling is how closely they mirror our present. We, too, are altering carbon levels, spiking methane concentrations, and even beginning to test geoengineering schemes like aerosol injection to reflect sunlight. The difference is that we can see ourselves doing it now, while the traces of supposed predecessors are buried in records, millions of years old. The patterns are not just similar, they are nearly identical, down to the timing and persistence of gas concentrations. It raises a haunting possibility that Earth has hosted multiple rounds of technological civilizations, each experimenting with atmospheric control, each leaving behind chemical echoes in the air, and each ultimately vanishing after pushing too far. If so, then our atmosphere is not only our inheritance, but also our warning. It preserves the lessons of deep time, lessons etched in air that say, others were here, others tried what we are trying, and the planet remembers. The question is whether we will follow the same path, leaving nothing but frozen traces for some future intelligence to puzzle over, or whether we will be the first to learn from the atmosphere's coded archive and break the cycle. Extinction is one of Earth's most persistent rhythms, a drumbeat that has echoed across deep time. Species rise, flourish, and vanish, often in waves so sudden and devastating that they reset the entire course of life. For centuries, scientists have attributed these mass extinctions to natural disasters. An asteroid strike here, a volcanic super-eruption there, perhaps climate shifts so severe that no species could adapt. But the closer we study the fossil record, the more disturbing patterns emerge, patterns that hint at something far stranger than blind chance. Extinction at times looks almost selective, as though guided by an unseen hand, targeting some organisms while sparing others, pruning the tree of life with eerie precision. Consider the Great Dying, 25.2 million years ago. This cataclysm, the deadliest known extinction event, wiped out around 96% of marine species and 70% of terrestrial vertebrates. If nature alone had caused it, the devastation should have been random, sweeping away species across ecological niches without discrimination. Yet the fossil record tells a more curious story. Entire groups vanished completely, while closely related organisms with similar vulnerabilities endured. Some lineages that appeared fragile persisted while robust species collapsed overnight. Such surgical precision defies the blunt hammer of volcanic eruptions or asteroid impacts. Instead, it suggests a mechanism capable of distinguishing not just between species, but between specific biochemical traits, as though life itself was being targeted at the molecular level. Further anomalies arise when we look at the Ordovician Silurian extinction about 445 million years ago. This event decimated nearly 85% of marine life, but the recovery was bizarrely rapid. New species appeared almost immediately, already well adapted to the changed environment. Evolution, under natural processes, should take millions of years to rebuild ecosystems after such devastation. Yet the fossil record shows replacements arriving ready-made, as though prepared in advance. Were these sudden appearances the result of hidden evolutionary pathways? Or could they have been the consequence of deliberate biological engineering, extinction clearing the stage for a new caste of life forms already designed to thrive? The chemical record adds to the unease. In rock layers marking extinction boundaries, scientists have identified strange concentrations of compounds resembling synthetic toxins, substances not typically found in nature, yet devastatingly effective at disrupting biological systems. These compounds appear dispersed globally, showing up simultaneously across continents and oceans, as if deployed in a coordinated release. Volcanic gases or meteor impacts might poison environments, but their byproducts are messy, inconsistent, and geographically localized. These extinction boundary toxins look systematic, precise, and planet-wide. Their chemical fingerprints hint at something engineered, a weapon tailored for mass elimination, on scales that dwarf anything humans could currently achieve. And then there is the nuclear question. Some extinction boundaries contain isotope anomalies identical to those produced by nuclear detonations, ratios of certain elements that cannot occur naturally except under the controlled chaos of fission. These isotopes appear in layers exactly coinciding with extinction peaks. It is one thing to imagine volcanoes belching carbon or impacts scattering iridium. It is another to entertain the idea that extinctions might have been triggered by deliberate nuclear warfare, waged not by humans, but by civilizations lost to deep time. The concentrations of these isotopes in some strata would require thousands of detonations, not a single catastrophic event, suggesting global campaigns of destruction rather than random accidents. Equally haunting are microscopic remains embedded in sediments from extinction periods, fragments of organisms that appear genetically modified, their DNA sequences showing signs of artificial design. These remnants suggest that bioweapons engineered microorganisms built to collapse ecosystems may have played a role in wiping out life. Some of these microfossils show features too advanced for natural biology, including genetic circuits optimized for precision targeting of metabolic pathways. The implications are staggering. If true, extinctions may not simply have been natural resets, but calculated interventions, clearing the planet for civilizations to rebuild ecosystems in their own image. The Cretaceous-Paleogene extinction, famous for ending the reign of the dinosaurs, may offer the most unsettling twist. Yes, the asteroid left its unmistakable crater in Chicxulub, Mexico. But the isotopic evidence inside the crater contains anomalies that suggest the asteroid's trajectory was anything but random. Certain ratios in the rock resemble signatures of nuclear propulsion, as though the asteroid had been deliberately nudged toward Earth. If accurate, it would mean that one of the most iconic natural disasters in history may actually have been engineered. The ultimate act of cosmic-scale terraforming, designed to wipe out dominant species and open the way for others to flourish. Taken together, these clues force us to reconsider extinctions, not just as chaotic accidents of geology or astronomy, but as potential evidence of technological intervention on a planetary scale. They suggest civilizations with the capability to manipulate ecosystems, weaponize biology, and even steer celestial bodies. And they whisper of cycles repeating, civilizations rising, wielding unimaginable power, then vanishing into the same fossil record they may have helped to sculpt. The chilling question remains: were these acts of survival desperate measures to reset failing ecosystems, or were they deliberate exterminations, erasing competition so that a chosen life could dominate Earth anew? If extinctions were engineered, then our planet's history is not a story of random catastrophe, but of calculated resets, and humanity may just be living in the aftermath of someone else's design. Antarctica is a place shrouded in silence, a continent buried beneath 2 miles of ice, untouched by sunlight for millions of years. To most people, it is a barren wilderness, frozen and lifeless, but scientists who drill deep into its ice sheets know that Antarctica is also a library, a vault of secrets that no other place on Earth can preserve. Every layer of snow that fell and compacted into ice is a page in the planet's diary, trapping ancient air, dust, and even fragments of DNA. The ice cores pulled from this frozen archive have revealed climate shifts, volcanic eruptions, and atmospheric changes stretching back hundreds of thousands of years. But deeper drilling, far beneath the youngest ice, has uncovered something that should not exist. Evidence of industrial activity and artificial structures entombed long before humans walked the Earth. Ground-penetrating radar surveys have mapped out geometric formations under the ice, patterns too regular and too extensive to be explained as natural. These formations stretch for miles, resembling vast complexes built with precision, their angles and alignments echoing the hallmarks of intentional design. Geologists first dismiss them as anomalies, tricks of the radar, until repeated scans from different missions produce the same results. Whatever lies beneath the ice is massive, deliberate, and older than the ice sheet itself, which suggests that Antarctica once hosted not just life, but an advanced civilization capable of engineering on continental scales. The ice itself carries even more disturbing evidence. Trapped air bubbles recovered from extreme depths show atmospheric compositions inconsistent with natural processes. At certain layers, oxygen and carbon dioxide ratios abruptly shift in ways that mirror large-scale industrial activity, the kind we associate with modern factories and fossil fuel combustion. Some layers even contain traces of synthetic compounds, molecules that do not exist in nature, but which humans only learned to manufacture in the last century. Yet here they are, perfectly preserved in ice that is hundreds of thousands, even millions of years old. If these compounds are authentic, they point to civilizations long gone, their chemical fingerprints frozen in time like a warning. Adding to the puzzle, organic samples recovered from sediments beneath the ice reveal genetic sequences that show unmistakable signs of artificial modification. Tiny fragments of DNA belonging to organisms adapted to extreme cold and darkness carry structures that look engineered, genes optimized for metabolizing synthetic compounds, resistance to radiation, and survival in hostile environments. These organisms may have been designed for industrial use, tailored to thrive in an Antarctic landscape dominated not by glaciers, but by vast technological complexes. Their presence suggests biotechnology that far exceeds current human capabilities, and it raises the chilling possibility that Antarctica once supported a civilization that reshaped entire ecosystems for its own survival. The evidence does not stop there. Mineral deposits uncovered beneath the ice contain unusually concentrated rare earth elements arranged in patterns consistent with large-scale mining. These concentrations are not scattered randomly, but occur in precise layers, as though extracted and processed using techniques that left unmistakable geological signatures. Drilling operations have even recovered microscopic machine components, tiny fragments of alloys and composites that cannot be explained as natural formations. Under analysis, some of these fragments display nanostructures designed for mechanical function, intricate patterns that imply manufacturing processes we have not yet mastered. They are the remains of machines that once operated in a world now buried beneath endless sheets of ice. Equally unsettling are the anomalies detected by electromagnetic surveys, which reveal buried power networks spanning hundreds of miles. These networks appear to harness geothermal energy, distributing it across vast areas in ways that suggest a unified energy grid. The capacity of such a system, if active, would exceed anything humanity currently produces. Some scientists propose that the civilization beneath the ice may have been responsible for triggering the very ice age that buried them. Chemical signatures in the deepest ice layers show rapid cooling events inconsistent with natural climatic shifts, hinting at geoengineering on a planetary scale. If true, it would mean that they froze themselves into extinction, either as a desperate act of preservation or as an intentional time capsule designed to hide their existence until another civilization was capable of finding it. Even more tantalizing are radar scans that suggest enormous structures resembling launch complexes, positioned in areas that would have provided optimal access to polar orbits when Antarctica was ice-free. These facilities may have been spaceports, the staging grounds for a civilization that reached beyond Earth. If true, then what lies beneath Antarctica is not just the ruins of an ancient city, but the skeletal remains of a global and possibly interplanetary civilization. The ice has protected their secrets for millions of years, but it is also hiding something that could upend everything we believe about history. Were these civilizations wiped out by their own hubris, their technology entombed beneath a continent of ice? Or are the buried structures still active, waiting for the day when the ice retreats and their secrets are revealed? Antarctica is not a frozen wasteland. It is a vault, a silence that holds answers to questions we may not be ready to confront. When scientists search for extraterrestrial intelligence, they often look for what they call techno-signatures, clues that a civilization has left behind through its technology. These can be artificial radio signals, unusual atmospheric pollution, or massive engineering projects visible from space. The idea is simple. Even if we never meet another civilization face to face, its technology should betray its existence. But what happens when researchers turn that same lens inward, applying those methods not to distant exoplanets, but to Earth's own geological record? The results have been unsettling, because the same kinds of techno-signatures that astronomers hope to detect in the cosmos appear here on Earth, buried in deep time, in rock layers, sediments, and ice that predate human civilization by millions of years. It's as though the planet itself has been whispering clues, only we lacked the tools to hear them until now. Spectroscopic analysis of ancient rock formations has revealed atmospheric changes that mirror the chemical fingerprints of industrial activity. Synthetic compounds, isotope anomalies, and unexplained pollution layers appear again and again in the record, separated by millions of years. These anomalies don't align neatly with known natural events such as volcanic eruptions or asteroid impacts. Instead, they follow patterns of precision and repetition, suggesting deliberate industrial processes. If alien astronomers on another world were looking at Earth during those periods, they might have marked us as a planet inhabited by an intelligent, technological species, long before humans ever appeared. The unsettling implication is that our planet may have hosted civilizations multiple times, each rising to prominence, reshaping the atmosphere and then vanishing, their only legacy the chemical scars left in the air and soil. Electromagnetic surveys of deep geological structures have uncovered buried anomalies that behave like remnants of massive engineering projects. These aren't the crumbling ruins of stone cities, but vast patterns woven into the very geology of the Earth. Patterns that only become apparent when viewed on planetary scales. Some resemble continental-scale transportation systems, while others mimic power distribution grids, detectable not as surviving infrastructure, but as persistent disruptions in magnetic and gravitational fields. They are signatures of technologies that may have become so deeply integrated into the planet's systems that they blur the line between artificial and natural. To us, they appear as mysterious formations. To their creators, they were the backbone of civilization. Satellite imagery has revealed geometric patterns in landscapes that resist natural explanation. Visible from orbit but nearly impossible to notice at ground level, these formations hint at construction projects so vast they could only have been designed with aerial or orbital perspectives in mind. Their symmetry, scale, and precision suggest deliberate planning on a planetary level, the kind of engineering humans only fantasize about in science fiction. These might be what scientists call mega-engineering techno-signatures, the fingerprints of civilizations that thought in terms of continents and oceans rather than cities and nations. Artifacts recovered from deep drilling projects add another layer to the puzzle. Occasionally, samples pulled from rock strata millions of years old contain fragments that bear unmistakable signs of advanced manufacture. These fragments aren't fossils or crystals, but composites, alloys or materials that would require high temperatures and sophisticated processing to create. Some display structural arrangements consistent with nanotechnology, microscopic designs optimized for strength, conductivity, or function, far beyond anything expected of natural mineral growth. Each discovery is usually dismissed as contamination, misidentification, or anomaly, yet the number of such anomalies is growing, and together they begin to sketch the outline of a disturbing possibility that we are not the first. The parallels between what scientists search for in distant star systems and what we are beginning to uncover on our own planet are impossible to ignore. In essence, Earth itself may already be an exoplanet with techno-signatures, one that would appear inhabited to an outside observer even in epochs when humans didn't exist. This realization has shifted the focus of some researchers. Instead of asking only, "Are we alone in the universe?" they now also ask, "Were we alone in our past?" If techno-signatures can endure for millions of years in Earth's record, then we must consider the possibility that civilizations before us left their mark, and that we are only now developing the tools to detect them. What makes this even more unnerving is that many of these signatures, pollution spikes, synthetic compounds, altered isotope ratios, mirror exactly what our own industrial civilization is producing today. We are laying down the same geological markers that someone millions of years in the future could interpret as proof of a long-vanished technological species. If our story ends in collapse, we will join those who came before, reduced to nothing more than chemical anomalies, buried artifacts and faint echoes, detectable only by those who know how to look. The search for techno-signatures, then, is no longer just a hunt for aliens among the stars. It is a mirror, reflecting back at us the haunting question of how many times this cycle has already played out on Earth, and whether we too are destined to vanish, leaving behind nothing but the faint trace of our existence etched into stone and ice. Earth's history is punctuated by catastrophe. The fossil record reveals 5 great mass extinctions, each of them wiping out the majority of species in what seems like the blink of a geological eye. Scientists traditionally attribute these events to natural disasters, asteroid strikes, volcanic supereruptions, sudden climate swings. Yet when you study the details of these extinctions, unsettling anomalies begin to emerge. Patterns that don't look random, but selective, almost as though the destruction was designed. Entire groups of organisms vanish overnight, while others, often less robust or less numerous, survive almost untouched. It is the kind of selectivity you would expect, not from blind nature, but from a deliberate hand, guiding which species should endure and which should be erased. Take the Permian-Triassic extinction, known grimly as the Great Dying around 352 million years ago. This was the worst extinction event in Earth's history, wiping out 96% of marine life and 70% of land vertebrates. Volcanism in Siberia is usually blamed, releasing vast quantities of carbon dioxide and methane into the atmosphere. Yet the chemical traces left in those rocks tell a more complicated story. Some layers contain synthetic-looking toxins that don't align with any known volcanic byproducts. They appear targeted at specific biochemical pathways, wiping out entire categories of organisms while leaving others relatively unscathed. Fossilized microorganisms from those layers reveal genetic structures that seem altered, almost as if engineered to behave differently than natural evolution would predict. If such compounds and organisms were indeed manufactured, then the Great Dying may not have been nature's accident at all, but a deliberate reset engineered on a planetary scale. The Ordovician Silurian extinction, nearly 4.5 million years ago, shows a similar strangeness. Roughly 85% of marine species disappeared, and yet the survivors were not always the strongest or the most adaptable. Instead, it looks as if ecosystems were cleared in a way that left room for entirely new life forms that emerged almost immediately afterward, already perfectly suited to the altered world. Traditional explanations. Ice ages triggered by shifts in atmospheric carbon dioxide cannot fully account for the speed and precision of the transition. It resembles not random chance, but ecological engineering, a forced collapse and replacement of life on Earth. Even the famous asteroid strike that ended the reign of the dinosaurs may not be as simple as a rock falling from the sky. The Cretaceous-Paleogene boundary contains isotope signatures that are not consistent with natural asteroid composition. Some scientists have noted anomalies, suggesting that the asteroid's path could have been altered, possibly even directed, toward Earth. If that were true, the extinction of the dinosaurs was not just bad cosmic luck, but a deliberate act, one that paved the way for mammals and eventually humans to rise. If civilizations existed before us, this raises a haunting possibility. Did they guide these extinctions, choosing who would inherit the planet after them? Throughout multiple extinction events, radioactive isotopes also appear in suspicious concentrations. Certain layers contain elements that can only be produced through nuclear reactions, not natural geological processes. They are the same isotopes created during weapons tests in our own time. Their presence in rocks, tens or hundreds of millions of years old, suggests that nuclear technology was deployed on Earth long before humans learned how to split the atom. If true, then some mass extinctions may have been acts of war on a scale so vast that they reshaped the entire biosphere. The correlation between isotope spikes, sudden die-offs, and the rapid emergence of new species cannot be easily dismissed as coincidence. This pattern repeats. Ecosystems collapse abruptly, often with a precision that spares just enough biodiversity to restart the cycle. New life appears fully formed, already adapted, as though waiting for its cue. It is as if Earth's history is not a random tale of chance and survival, but a managed sequence of experiments, each one wiping the slate clean before introducing the next design. Whether these orchestrations were meant as corrections, experiments, or weapons, the result is undeniable. Earth's evolutionary story is littered with resets that look suspiciously engineered. For decades, we've comforted ourselves with the idea that extinctions are tragic but natural. But if even one of them was guided, it changes everything we believe about our place in time. We would not simply be the lucky survivors of cosmic accidents, but the inheritors of a planet whose history has been repeatedly rewritten by hands we cannot see. And if extinctions were engineered in the past, the most unsettling question becomes, could it happen again? Antarctica, the frozen desert at the bottom of the world, is usually imagined as a lifeless expanse of ice and snow. For millions of years, it has been sealed away, untouched and inaccessible. Its secrets locked beneath 2 miles of ice. But recent research and technological advances in ground-penetrating radar, ice core drilling, and satellite imaging have begun to peel back the layers of this icy shroud. What they reveal is unsettling. Evidence that beneath the ice lies not just geological history, but signs of something that looks engineered, intentional, and impossible to dismiss. Scientists expected to find ancient forests, or perhaps traces of long-lost ecosystems buried beneath the ice sheet. Instead, radar surveys have revealed vast geometric patterns stretching across hundreds of miles, too regular to be the work of nature. Straight lines intersect at precise angles, forming shapes that resemble foundations, corridors, and even massive structures that extend deep into the bedrock. Natural geology rarely forms such symmetrical designs on this scale. These patterns echo the fingerprints of construction, suggesting that an entire civilization, perhaps even a continent-spanning one, may be frozen in time below the Antarctic ice. The idea sounds like science fiction, but Antarctica has not always been the barren wasteland we know today. Roughly 30 million years ago, the continent was lush and temperate, covered in forests, rivers and life. Fossilized trees, preserved pollen, and even dinosaur remains have been found along its coasts, proving that this frozen world was once thriving. More recently, just a few million years ago, climate records suggest Antarctica may have experienced warm interglacial periods, with areas free of ice and capable of supporting complex life. If advanced civilizations had arisen in deep time, Antarctica would have been a prime candidate for settlement, with abundant resources and strategic access to both the southern oceans and orbital trajectories above. And if such civilizations existed, the encroaching ice could have buried their remains, preserving them for millions of years in conditions more stable than almost anywhere else on Earth. Ice cores drilled in recent decades have added fuel to this fire. Deep samples reveal atmospheric compositions that should not exist, with spikes of greenhouse gases and synthetic compounds embedded in layers dating back hundreds of thousands of years. Some of these chemical traces mirror what we see from modern industrial activity, suggesting that large-scale atmospheric manipulation occurred long before humans began burning fossil fuels. Stranger still, organic material preserved beneath the ice contains DNA fragments that appear modified, carrying sequences inconsistent with natural evolution. These fragments hint at organisms engineered for specific purposes, perhaps agriculture, perhaps industrial processes, designed to thrive in cold, low-light environments. If this is true, it suggests not only that a civilization once existed beneath the Antarctic sky, but that it harnessed biotechnology far beyond our own capabilities. More astonishing are the mineral deposits discovered under the ice. Surveys have revealed concentrated veins of rare earth elements and metals arranged in patterns that suggest deliberate extraction and processing. Natural deposits typically scatter unpredictably, but here they appear aligned as though mined systematically, their distribution resembling industrial-scale operations. In some cases, cores pulled from these deposits contain microscopic fragments of synthetic materials, compounds that don't occur naturally and would require advanced manufacturing techniques to create. Such findings point to a level of technological sophistication that should not exist in deep geological time, unless Earth's history is far more complicated than we've been taught. Then there are the radar echoes that suggest buried structures designed for power generation. These formations align with geothermal hotspots beneath the Antarctic crust, hinting that whoever lived there may have tapped into geothermal energy on a scale humanity has only begun to explore. Networks resembling conduits and distribution channels stretch for miles, as if vast power grids once ran beneath the ice. Some researchers speculate that these could represent remnants of facilities designed to harness and control Earth's energy flows, not just for survival, but for planetary-scale projects. When viewed together with atmospheric anomalies and genetic traces, these discoveries begin to form a disturbing picture of a civilization capable of climate engineering and technological feats that rival or surpass our own. And yet, the most haunting clue may not be what is buried, but what is missing. Why did such a civilization vanish? Did they succumb to the same cycle of overreach and collapse that seems to haunt all technological societies? Or did they take a more drastic measure, deliberately engineering their own disappearance? Some researchers suggest that Antarctica's sudden and extreme glaciation may not have been a natural climate shift at all, but an intentional act. By cooling their continent and burying their achievements under miles of ice, perhaps they sought to preserve their legacy for future civilizations to discover. It would be the ultimate time capsule, frozen for millions of years, awaiting a species advanced enough to recognize and decode it. As evidence accumulates, one thing becomes clear. Antarctica is not just a wilderness of ice. It may be a vault of history, a frozen library holding the remnants of an advanced civilization erased from the surface, but preserved beneath the cold. If the patterns, anomalies, and artifacts are what they appear to be, then Antarctica is not merely Earth's last frontier of exploration. It is the resting place of secrets that could rewrite the story of humanity and of every civilization that came before us. Deep within the Earth's crust, far beyond the reach of ordinary exploration, lie mineral formations that appear natural at first glance, but reveal patterns too precise and too functional to dismiss as chance. These crystalline structures, arranged in vast networks, stretching through caverns and fault lines, display geometric order and electromagnetic properties that hint at something extraordinary. They may not be mere rocks at all, but the remnants of an ancient technology so advanced it blended seamlessly with the planet's geological processes. Unlike the metal machines or digital devices of our age, these crystalline systems seem to have been built to endure deep time, surviving not for centuries but for millions of years, encoding information, storing memory, and perhaps even exhibiting a form of computation that operates on geological timescale. When scientists first analyzed samples of these unusual formations, they discovered repeating lattice structures that encoded mathematical constants far too complex to have emerged spontaneously. Some crystals contained layers of molecular alignments that mirrored binary systems, while others showed arrangements corresponding to fractal equations used in modern computational design. The conclusion, though controversial, became difficult to avoid. These crystals may represent a form of data storage technology, designed to use the stability of mineral growth itself as a canvas for information. Unlike paper, stone, or even digital servers, such crystalline archives could last indefinitely, immune to fire, flood, erosion, or ice. It is as if a forgotten civilization understood that geology itself was the only medium capable of preserving their knowledge across epochs. Further analysis revealed something even stranger. When exposed to electromagnetic fields, certain crystals seem to respond with measurable energy shifts, as though reacting to stimuli. Patterns in their resonance hinted at stored instructions or even the ability to process input. Some researchers proposed that these were not passive storage systems, but active computers, networks of crystalline processors operating through the fundamental properties of matter. If true, this would mean that ancient civilizations harnessed the natural processes of crystal growth and lattice vibrations to create a form of quantum computing embedded within the planet itself. Unlike our fragile electronic circuits, these geological computers could operate indefinitely, powered by geothermal heat, seismic vibrations, or the planet's magnetic field. The possibility raises a chilling question. Could some of these systems still be operating today, silently running calculations beneath our feet, guiding geological activity, or even influencing the trajectory of life on Earth? Mining expeditions have uncovered vast networks of these formations, stretching for miles underground, their structures interconnected in ways that resemble communication pathways. These crystalline networks appear to transmit energy and information through seismic pulses, electromagnetic waves, and resonance harmonics, effectively turning entire rock formations into massive distributed systems. Evidence suggests that some of these networks regenerate when damaged, with fractured crystals regrowing into their original lattice structures, as if programmed to self-repair. This kind of resilience implies design, not accident, technology that adapts and sustains itself even in the face of earthquakes, tectonic shifts, and volcanic upheavals. If such systems truly exist, they may represent the earliest form of artificial intelligence, not electronic or biological, but geological machines made of rock, thinking on timescales humans can barely comprehend. The implications are staggering. Imagine civilizations that recognize the fleeting nature of steel, concrete, and silicon, and instead chose to embed their most vital systems into the living body of the Earth. Their computers would not hum in server rooms, but resonate in caverns. Their memory banks would not degrade after decades, but endure for millions of years. And their influence would not be limited to technological tasks, but could extend to planetary management itself, controlling volcanic activity, balancing atmospheric chemistry, or even shaping evolutionary pathways through subtle manipulations of environmental conditions. Some scientists argue that anomalies in earthquake patterns, mineral formation rates, and even magnetic field fluctuations may not be random at all, but outputs of these hidden crystalline systems still running long after their creators disappeared. Most unsettling of all are the discoveries that suggest these systems contain not just technical data, but cultural archive. Certain crystal formations exhibit encoded sequences resembling symbolic language, with patterns that repeat in ways consistent with narrative structures or records of knowledge. In essence, they may be libraries written in stone, preserving the stories, philosophies, and warnings of civilizations lost to deep time. If we could fully decode them, we might uncover the thoughts and intentions of beings who lived millions of years ago. Were they leaving instructions for their successors, hoping someone like us would one day find their legacy? Or were they embedding control systems to ensure that even in their absence, the Earth would continue operating within parameters favorable to life? The possibility that the Earth itself houses an ancient, self-sustaining intelligence forces us to rethink what technology means. It may not always take the form of machines we recognize. It may be embedded in crystals, resonating in silence, waiting for us to learn how to listen, and perhaps, just perhaps, The Earth's steady balance across billions of years owes less to random chance and more to a forgotten civilization that built machines not of metal or plastic, but of stone and light, designed to endure forever. Far above our heads, beyond the reach of human history and conventional archaeology, drifts a silent graveyard of secrets. While modern satellites and space debris populate the skies with recognizable human-made objects, scientists have uncovered anomalies in orbit that predate our own ventures into space. These discoveries have sparked a new discipline known as space archaeology, the search for evidence of ancient technological activity preserved in Earth's orbital environment. Unlike artifacts on the surface, which face erosion, decay, and geological upheaval, space provides near-perfect conditions for preservation. In the vacuum above Earth's atmosphere, objects can remain stable for millions of years, their metals uncorroded, their structures intact, and their presence hidden from all but the most careful observation. What researchers have begun to detect are not random natural satellites or chunks of rock, but engineered structures locked into stable orbits, some positioned in places where no natural object should exist. Among the most puzzling are artificial bodies discovered near Earth's Lagrange points, locations where gravitational forces balance to create stable positions in space. These points are cosmic parking spots, where satellites can remain indefinitely without expending energy to correct their course. Modern scientists use these positions for observatories and monitoring stations, but the newly detected objects suggest someone else may have known about them long before us. Their orbital stability means they could have been placed there millions of years ago, patiently circling the Earth and waiting to be discovered. Spectroscopic analysis of these bodies reveals material compositions that defy both natural formation and modern engineering. The alloys appear designed to withstand the intense radiation of space and micrometeorite impacts, with molecular structures arranged for resilience far beyond what human aerospace technology currently achieves. Some even show evidence of self-repair mechanisms, systems capable of using cosmic dust and solar particles to mend microscopic damage, ensuring survival across eons. Even more disturbing are the objects in eccentric, highly elliptical orbits that take them far out into the solar system before pulling them back toward Earth. These trajectories resemble deliberate long-range patrols, as if these artifacts were designed to observe both Earth and its planetary neighbors over vast cycles of time. Some of these structures are large enough to suggest they may once have served as orbital stations or manufacturing platforms, their designs optimized for long-term habitation or production. They display symmetrical features and geometric patterns that no natural body could produce, leading some researchers to speculate that they could be the remnants of orbital habitats abandoned by civilizations that vanished long before humanity appeared. Their placement in distant orbits suggests deliberate attempts to avoid detection by surface-based observers while maintaining oversight of planetary activity from afar. But the evidence does not stop at passive relics. Radio telescopes have detected faint but persistent signals originating from some of these objects. The transmissions are not random static, but structured, with modulation patterns that imply intentional design. These signals repeat at precise intervals, carrying information across frequencies not typically associated with natural processes. The signals could represent automated monitoring systems still active after millions of years, sending data to destinations we cannot identify. The unnerving possibility arises that these objects were part of a communication network designed to observe Earth's biosphere and technological development, reporting back to unknown recipients or perhaps to no one at all, continuing their duties long after their creators disappeared. Closer to home, studies of the Moon's surface have revealed buried anomalies detectable through ground-penetrating radar. Beneath the lunar regolith, researchers have found geometric voids, and reflective surfaces arranged in patterns inconsistent with natural cave systems. These structures, located in regions shielded from Earth's view, appear to have been constructed deliberately. They resemble mining facilities or underground stations, taking advantage of the Moon's resources and stable environment. The idea that ancient civilizations used the Moon as both a base and a manufacturing hub is not as far-fetched as it seems. Its low gravity and lack of atmosphere would have made it an ideal location for launching materials into space, constructing orbital networks, or fueling interplanetary expeditions. Evidence of electromagnetic anomalies near these sites suggests the remnants of power systems, perhaps once harnessing solar or geothermal energy to sustain operations. Mining activity has also been observed on near-Earth asteroids. Some asteroids show signs of systematic excavation, their surfaces cut into with precision and their masses altered in ways inconsistent with natural collisions. These modifications suggest large-scale resource extraction, as if ancient civilizations stripped asteroids of valuable metals and transported the materials elsewhere. Modern humanity has only begun dreaming of asteroid mining, yet the scars of such activity may already exist, etched into rocks that silently orbit the Sun. The question is not whether it is possible, but who or what was responsible. Space archaeology forces us to confront a daunting possibility that we are latecomers to an ancient game, inheriting not only Earth but its orbital environment from civilizations that treated the solar system as their workshop. Their artifacts drift silently above us, waiting for recognition, hinting at ambitions and capabilities far beyond ours. If they could build orbital stations that survived millions of years, engineer self-repairing satellites and carve asteroids into raw materials, what else might they have accomplished? And if their relics remain, what does that say about their fate and about the dangers that might await us if we follow their path too closely? As we draw this journey to a close, one undeniable truth emerges. Our world is not simply the cradle of humanity. It is a vast archive of secrets written across stone, ice, and stars. The evidence we have examined, whether iridium anomalies, synthetic particles buried in ancient sediments, nuclear isotopes that should not exist, or silent machines drifting in stable orbits, forces us to confront a possibility more staggering than any myth or legend. We may not be the first to walk this road of fire and steel. Civilizations may have risen and fallen on this very planet long before our species even learned to stand upright, each leaving faint traces that whisper of power, ambition, and catastrophic collapse. The fossil record's sudden leaps, the chemical spikes in ice cores, the engineered polymers found where no natural process could have created them. All of these are not fragments of fantasy, but persistent puzzles carved into the bones of Earth itself. And they remind us of something uncomfortable: time is merciless, and even the greatest achievements can be swallowed by it. If technological societies truly existed before us, then the cycle becomes clearer. They flourished, they expanded, and they consumed. They engineered their environments, perhaps even their skies, pushing their sciences to levels we cannot yet imagine. And then, abruptly, they vanished. Some may have destroyed themselves in nuclear fire or genetic tampering gone wrong. Others might have succumbed to natural disasters their arrogance told them they could control. Still others may have transcended biology altogether, leaving behind only quantum signatures and encoded warnings in stone. But whatever the cause, their silence echoes louder than their presence. For every discovery that hints at their brilliance, there is the haunting absence of their voices. No monuments stand untouched, no histories endure, only the quiet evidence etched into Earth's fabric that says, "We were here, and we failed." This realization should not terrify us, it should sober us, because now, for the first time, a civilization on Earth possesses the perspective of deep time. We can see the cycle clearly. We can measure the spikes of carbon dioxide in ancient ice and compare them to the ones we ourselves are creating. We can look at sediment layers filled with synthetic particles millions of years old and recognize how similar they are to the plastic we are now dumping into our oceans. We can read the isotope ratios that scream of artificial nuclear reactions and see our own weapons mirrored in them. Where once ignorance excused destruction, now knowledge makes it a choice. And that is where our story differs from the ones that came before. Unlike our predecessors, we stand connected by instant communication, capable of sharing warnings and insights across the globe in a heartbeat. We have mapped our planet and charted our skies. We understand ecosystems in ways earlier societies may have ignored or misunderstood. Most importantly, we have access to their failures, etched into stone, ice, and orbit, like caution signs left for us to heed. If the cycle of rise and collapse is written into the fabric of technological development, then perhaps it is also written that one civilization must eventually break it. And if that is true, then we have a responsibility unlike any before us. The conclusion is not that doom is inevitable, but that history is offering us a choice. We can ignore the echoes of deep time and follow our predecessors into oblivion, or we can learn from them, adapt, and finally succeed where they did not. The knowledge left behind, whether encoded in crystalline networks, in the genetic traces of engineered organisms, or in silent machines still orbiting above us, is not just a record of their existence. It is a gift, a lifeline, a plea across millions of years that says, take what we learned and do better. Humanity now has the chance to honor that legacy by ensuring we are not simply another layer in the fossil record, another mysterious spike in carbon, another inexplicable extinction. We can instead be the civilization that endures, the one that breaks free of the cycle, the one that ensures Earth's long story of intelligence finally finds a chapter that does not end in silence. The choice rests in our hands, and the clock of deep time is already ticking.